All right, and we
Okay.
are live.
Hiya, folks. Welcome. We're back. Azure Cloud Native is back and returned. So we have Michael with myself. We have Michael and Richard, the organizer, and myself, Nicholas. So hi, everyone. So
Hello.
and then today's session we have a speaker, Alessandro. Sorry if I pronounced it wrong.
It's, it's
Yeah,
Alessandro. Alessandro. That's
Alessandro. Yeah,
Alessandro.
yes. I'm
yeah,
Italian, by the way.
yeah. He's speaking about KEDA and container. So if you don't know about KEDA, what it is and what it's used for in cloud native, stay tuned. You want to say anything else? Mm.
Yeah, just for me, it's good to be back, and thanks for you guys for
Yeah,
joining us with the Azure Cloud Native. Yeah, it's good to get a bit of life back into the user group, and hopefully people start joining, and we'll get some awesome content out there. We're
yeah.
all passionate
So
about this, so it's all good.
yeah, so the idea is to make it into a theme, cloud native theme. So one theme does not. The next episode will be a different theme. So in cloud native, yeah.
Anything from you, Mike?
I'm just really happy to be here. I'm happy Richard and Nicholas asked me to come on this journey because obviously all the community stuff that we do is super important, and
Yeah.
getting whoever we possibly can that wants to hop on camera and talk cool Microsoft Azure things with us is obviously welcome, and it's a super cool thing to just be able to kick this off to the community for everybody, and that's what I'm excited about because we're all writing code and doing engineering things all day long, and it's nice to just hop on camera and say what's up to everybody and just enjoy everybody's time.
Yeah.
All right, I guess Alessandro, do you want to take it away?
Thank you, and to first of all, I'm so humbled to be in the presence of such trio of Azure masterminds. You guys really pushed the envelope. I follow each one of you for a long time, and I didn't know that today I would find all three of you together. So that's a nice surprise. And indeed, like Michael said, it's the people, right? So this cloud native thing is, it's some code. By the way, most of this code now is written by our AI overlord. So it's just, but they cannot replace. I mean, we cannot send an AI to KubeCon, right? So we need to be there. We need to show our face and have interpersonal communication. That's so important now. So I'm very happy to be part of this. Again, like it's only me today, so I'll take my time. I'll show you what I did show this a month ago to a local meetup. So I just refined the demo. It's still not perfect, but it does work. Or at least show some technologies. And it's not only KEDA. Actually, today I'm gonna show a bunch of stuff, including Azure load testing, service bus, of course. We need something to look at, some thing that collect some messages, and then we can do something about it. And of course, things like manage Grafana and a bunch of other tools in Azure. So because I have some time, so I'm just gonna go through slowly. I'm gonna fire up the portal, and I'll show you what I do when I work on this thing. So I think you can see the slides, right? So
Yeah, you're good.
So yeah, we're gonna talk about why autoscaling matters, especially now. This is the time. I think you can see CNCF tag environmental sustainability. It's one of the topics that is very dear to me. So we're gonna talk about why autoscaling matters, especially because we live in a time where we cannot just turn on virtual machines or clusters and leave them on mindlessly. We need to care, right? So we need to really understand what we're doing and why, and how, and if we can make it better for the planet. I don't know you guys, but I got kids, so I would like to leave them a better planet that I found. It's not working that well still, but maybe we can do. Maybe we can make a difference, right? So
And with that, real quick, I'll just say shout out to the sustainability working group over at CNCF. Awesome folks over there doing a lot of really, really great things.
Yes, thanks to Leo, Nikki, Christina, and many more. Unfortunately, actually, not unfortunately, but the tags, and you Michael know, and all the tags are going to be reshuffled, and we are far in the process now. So we don't know. It's not going to be called tag moving forward, but something is going to happen, and we need the input of everybody, everyone that has some interest in making the software greener. This is the time to contribute. So you can reach out to me, Michael, or come to Slack for the CNCF tag. We still have the channels called tag environmental sustainability, but who knows? In the coming months, something's gonna happen. We're gonna migrate to community or initiative or something. Something's gonna happen. So that's why I didn't put it there, because it's actually it's the last months of the tag. So I'm a former CNCF ambassador, so I stepped down not too long ago, but I was a CNCF ambassador for the longest time. I used to be at Microsoft, and I'm back, right? So if you know me, I was very proud to be in Microsoft for, I think these are the best year for sure. But when I was there, when I joined Microsoft, wasn't part of the Linux Foundation, wasn't part of the Cloud Native Complete Foundation. There was no Kubernetes. There was barely any Linux to be spoken of. And I saw it all. I saw Microsoft completely reinvent itself. And I'm back because they are doing it again, becoming an AI first company. So that's I'm very proud to be working in Microsoft. It's something that I was really looking forward to go back, and exciting times, right? So I'm having so much fun with all the cloud native, but also the AI stuff, which I love to talk about AI, by the way.
Right. So one thing too, like for everybody that's watching, and a lot of people I feel like maybe don't know this, but because Microsoft is still very much looked at as like the enterprise solution or whatever, but Microsoft does, I'm saying this live and publicly, way more than the majority of organizations in the open source realm. There's a lot of contributions to open source from Microsoft. Microsoft is arguably leading one of the hugest paths around WASM, right? And a lot of app modernization stuff and a lot of other things that are open source. So shout out to the good folks that are doing all those good things over there.
Yeah, Microsoft was the second biggest contributor to the CNCF last year, I think it was, only beaten by Red Hat, which is really cool.
Okay.
And look at projects like EdLamp on the keynote. Shout out to Ralph and Andrew and all the many Microsoft people doing open source. It is the place for open source. I mean, I wouldn't be there if I wasn't. But I remember. So it's a long story. I'm 49, by the way. I just made 49. I have a lot of story. I was around open source in the very beginning, or at least when in 1999, I was part of the Linux user group in my town. We were suing Microsoft for real, like for patent infringement. And then 15 years later, I joined them. And I had to do some explanation to my friends why I did join the dark side. But then it was the first year of Satya Nadella. Everything was very, very, very more friendly to open source. And look at us now, right? So we are the year of the open source world. But let's not digress. By the way, I'm almost a golden Kube astronaut. 2 more exams and I'm there. If you don't know, it's if you get all the certifications, yes, go them open telemetry and backstage exams. But I think I'm gonna make it. And by the way, I live in Amsterdam. I run the Dutch Kubernetes Cloud Native Meetup for 9 years now, so that's a long time. And we are coming back also with a Cloud Native Amsterdam. It's actually a website. It's actually a top level domain called Amsterdam. So if you go to Cloud Native Amsterdam, you find that we are gonna come back with a big event in May 2026. we are postponing it to leave space for other events. But yeah, I love to do community. I love to do meetups. And if you ever come to Amsterdam, you're always welcome. You are my guest. Right. Now, first of all, if you, I don't know, I can see some, yeah, I can see the chat. So if I see like a urgent question, I will stop by. I will stop the flow and talk about answer the question. But in general, let me know if there's somebody who wants to intervene or stop me. So why autoscaling matters? And thanks for the long introduction, but I took this from Zbenek Rubalik from KEDA. I met him actually at KubeCon. He's a great guy. He works at a company that productize KEDA, so also offers enterprise feature for KEDA. It's very important to understand why autoscaling matters, right? So, and I don't know. I mean, I entered the world of IT before AWS, so I do remember all the fuss about like why the cloud really changes the paradigm of computing. So why autoscaling matters? Because workloads are all sorts of them, right? So there are all sorts of different workloads. Some of them are very predictable. Some of them are static, right? So there's just a bunch of pods running and they do their job. You don't really need to take care of them. Some of them are batch, right? So you can easily predict. You can schedule them when it's convenient for you. But some of them are actually really not predictable. And so autoscaling matters because it allows you to, this is not animated. Ooh, let me quickly change to instead share my screen, because I mean you don't want to miss my awesome. Tell me if you can see this, right? You see my screen?
Let's see this one. Let me put this one. Is that the right one?
Yeah. So
yeah.
I'm moving slides now. So yeah, why autoscaling matter? Because you want to follow the pattern of consumption of your workloads, right? You don't want to overspend, and you don't want to under provision your resources, right? So both are bad. Some, of course, over provisioning and under provisioning are bad for different reasons. For example, so over provisioning, it is safe, as in you are providing way more resources than you need to your workloads. So means that your users have a better experience. There's plenty of RAMs and CPU to go around, but it's still the devil is in the details, right? So you are wasting resources. Every CPU cycle, every gigabyte of RAM that is not really needed is there and is on and is consuming your money and emitting CO2 and consuming water and more waste for no reason whatsoever. So without a really useful purpose, right? So it is not great to over provision because of this waste, but it's even worse when you under provision, when you are not following close enough the peaks of demand of your users, whatever it is. Could be intentionally there's no scale here. It could be RAM, could be CPU, could be network traffic. Who knows? I mean, it could be anything that tracks the resource demand of your application. So under provisioning, this part here where you are not providing enough resources to your workloads, of course, is bad because latency, of course, it's bad for your user experience. And there can be this cascading effect, as in a few pods fall over because they are overstressed, they're going over the limits. And then everything started to really misbehave and go bad from there, right? So it's not only these problems tend to be not isolated, but then cascade over and becoming an avalanche of fail requests and 404s and 500 and so on, and it can easily lead to bad user experience, right? So, and you don't want that. So you don't want to be in any of this situation. You want to follow as close as possible your workloads in their demands, in their resource consumption. So this is simple to understand. It's very straightforward, right? So, but how you do that, right? So there are many dimensions to scaling, right? So especially in Kubernetes, so which is an orchestrator for workloads in the form of pods. Those pods carry resources, right? So they need resources, they consume resources, and they carry different dimension for scaling. First of all, is the classic. This was, I think, it's around since, I don't know, 1 point something, 1 point maybe 3 or 4. I remember when there was no HPA, but it was introduced and it was pretty smart to have an horizontal pod autoscaler. Actually, when, I don't know you, but I also used to give trainings. I always say you should always have a horizontal pod autoscaler for every deployment, right? So every deployment should have a pod autoscaler, even if you set the limits very close to each other, you don't really scale. But it's always good to have. It's a resource, it's an object in Kubernetes that controls one thing, and one thing only: the replica set, the number of replicas of a deployment. So this is horizontal scaling, as in more of the same, more copies of the same deployment, of the same pods. But each pod, of course, carries resources, requests, and limits, of course. And so the second dimension is the vertical size of each pod. So not only more of the same, but also bigger pods. Now, a pod is not bigger per se, it's the limits and the requests that the pod needs. They can be dynamically adjusted by the vertical pod autoscaler, which is not super popular. It is something that you don't get out of the box, so you need to install it. In that case, you actually have an add-on, I believe, to have vertical pod autoscaler. But honestly, I don't see it that much. Maybe now, with AI workloads, it could be more interesting to have vertical pod autoscaler that can adjust pods. And also, by the way, 133 was released this week. Finally, and that was actually one of the features of Kubernetes 133 is the dynamic adjustment of pod resources, right? So before, you had to restart the pod, right? So actually create a new pod with new resources and limits. So that would involve restarting pods, which is nobody wants to do. But now there's this, and I think there was a release notes of the release released just this week. So please check it out. I can leave a link in the comments. But so finally, vertically scaling pods becomes a bit more feasible, right? So because the pod itself can dynamically adjust its limit. So something I would like to look into it. But let's say that the vertical pod autoscaler is not something you usually want to do, or it's not something really common in Kubernetes. And of course, like all this, there's one more scaling dimension, which is the cluster itself, right? So all these pods scaled horizontally, they have to land somewhere. And if you run out of resources in your cluster, there's nowhere to go. So that's where the cluster autoscaler kicks in and gives you more resources. So all this, the first two, they deal with whatever resources you have in the cluster, so they don't scale node, but they might trigger cluster autoscaling events, right? So these are the three dimensions. They are orthogonal, as in you just have more pods, but all the same resources and requests. The vertical scales pods makes them bigger, and smaller when they don't need that many resources. And of course, cluster autoscale will overcome your limitation in resources of your cluster. So why? So the horizontal pod autoscale is the most common way to scale workloads, because you can just scale automatically based on metrics. But the metrics that the horizontal pod autoscaler deals with are pretty bare bone, right? So just understand only CPU and RAM metrics. Now, these are, most of the time they are okay. They're pretty good proxy for your consumption. In the end, you want to have a proxy for your user experience, right? So, but is it always true that if my pods are consuming a lot of CPU or RAM, does it translate into bad experience of my user? It's not always easy to draw the correlation between the two. And so you want to scale on different metrics that that can come from anywhere, Prometheus queries, for example, or in our case, the demo we're going to show on the queue length of service bus queue. But it can be anything, right? So it can be, there are many adapters in KEDA, and so you can see that there is a need to go beyond the simple HPI. So that's why 2019, I remember when it was announced, I think it was at KubeCon, of course, KubeCon Seattle, maybe, I don't remember, but maybe it was Barcelona. The KEDA project, the Kubernetes Event-Driven Autoscaler, overcomes the limitation of the horizontal pod autoscaler, integrates with it, and extends it to many more ways to understand the behavior and the patterns of workloads. So 2019, almost immediately donated to CNCF. It's like the textbook example for a open source project that is born in corporation like Microsoft and Red Hat, but immediately put on GitHub. Immediately, community was formed around it, was donated to as a sandbox, and through the years, of course, we gathering more interest and more traction. It became a CNCF graduated project in 2023, which means it's stable and there's a healthy community around it and so on. So it's a single purpose lightweight component, so it's just one operator, right? So it's not many components scattered around with just one thing that contains all the logic for the scaling. It works on any Kubernetes cluster, of course. Extend Kubernetes with event-driven capabilities. So it's the idea that the system is responsive to events. That's at the core of KEDA. It doesn't override. It doesn't replace HPA, but actually writes the horizontal pod autoscaler for the event that is based on the event that is and the specification that you define. And of course, you can scale different objects, including deployment set, deployment stateful set, or anything else really. It just, the target is just a target, so you can target different resources and you can scale them as needed. And it's very, very safe. As I said, it's a graduated project, so it's been, the code has gone through several rounds of security clearance and so on. So it is something that you, so much so that it's actually a add-on to AKS, right? So you can, and I'll show you how to install it with AKS when you create the cluster. So you don't even need to install it yourself. It's just a managed add-on in Azure Kubernetes Service. So it's really a no-brainer not using KEDA. So when I made the slide like a month ago, there were 72, but I just checked and now there are 74 scalars. I don't know which the two that were added in the last month, but definitely you see it's a healthy community. Adding more scalars is simple as writing the code, writing the plugin for KEDA to add any scalars that you want. So what is a scalar is the part of KEDA that responds to an external event, right? So in our case, we're going to use the service bus scalar, the Azure service bus, which is a way to connect to a service bus and read, for example, the number of messages in the queue, and then react on that signal, on that event. Most of the time you want to do, for example, Prometheus queries or RabbitMQ or something else, that, or even responding to GitHub events. So, and I'll show you. I have a slide took from Philip. Imagine you want to run GitHub runners in Kubernetes. That's a deployment, right? So that's a deployment that can scale from 0 to any number of runners that you want to run to accommodate all the incoming requests for jobs. But that's a scenario, right? So you have a scalar that can react to the number of jobs in a queue in the GitHub pipelines, in the GitHub actions, and then scale up as needed and scale down to when the jobs are done. So, and one thing that is very important for KEDA is that it can scale to 0. Something you don't get out of the box when you use deployments in Kubernetes. You can actually scale to the number of replicas can actually be 0. So these are the scalars. There are many possible scalars from blob storage, AWS. So it's really a cross-cloud agnostic project. The companies, open source project can contribute their scalars, and they will be gladly accepted by the KEDA project because they will expand the scope of the project itself. So it's quite simple. It's one component, right? So in the blue box, there is everything that KEDA is the KEDA controller. And so when there is an event, it triggers a change in horizontal pod autoscaler that eventually influence the number of replicas of the workload. So, and that can be between 0 and 1, or it can go from 0 to 1 and then n, or can scale from 1 to 0 even. So the workload is whatever you want to do. So in our case is a simple deployments that contains like consumers for the service bus, but can be anything, even jobs and well, I think jobs scale stateful sets, and daemon sets are daemon sets you cannot scale, of course. Scaled object, this is the core, right? So this is the most important thing you need to understand about KEDA. It's simple as the definition of what to scale, right? So the scale target reference. So in this case, I want to scale deployment. These are, and then scale how between 1 and 100. And then they are missing here, but there are other parameters you can define to influence the kind of scaling. So if you want to have like a cool down time before scaling up or down, or you want KEDA to respond more faster or slower to events. There are all sorts of parameters in the definition of the scaled object. So there's the first part, what to scale, and the second part is the trigger, right? So what to trigger on. And in this case, is you see like you just define a Prometheus server. You can also use an authentication. So the Prometheus server may need some authentication, so you can save that authentication in a secret or in a separate object called the trigger out reference. And once KEDA can access the Prometheus server, in this case at that server address, it will just make a query, right? So the query is the sum, so the number of requests in the last 5 minutes. And if that is above 100, it will trigger a scaling event. So simple as that. It seems simple, but it's actually very powerful. In this case, of course, instead of deployment, we want to scale a job. And these are, so you can see also you can specify the kind of containers you want, where to get the, if that container needs to get some secret from somewhere else, and so on. And the trigger is in this case is RabbitMQ. So scale to 0, as I said, do matter. So I took this from Philip Wells. It's actually pretty smart. I didn't implement it myself, but it makes sense, right? So let's say that you have GitHub actions and you running your own runners. It's very typical in enterprise environment. You don't want to rely just on the hosted runners. Azure DevOps, GitHub, same thing, right? So you can use the hosted runners, or you want to run your own. If you run your own, you also don't want to leave them on if there is no job queued, right? So you want to scale that. Whenever there is a new job, you want KEDA to react to that by polling the GitHub action, for example, and then scale. In this case, I think Philip implemented in Azure Container Instances. Same thing. You can use a Kubernetes cluster. Azure Container Apps. Sorry, Container Apps is just a simplified Kubernetes experience, but dynamic and scalable. So you can scale based on the number of jobs in the queue. The carbon-aware KEDA operator also was announced in 2022, 2023. I don't remember, but it's a scaler for KEDA that responds to different inputs, not just a queue or a Prometheus query, but for example, on the carbon intensity of a specific region at some point in time. So you can actually scale based on whatever you want, really. Like you can scale based, for example, on, you can create this carbon-aware KEDA scaler that can take action wherever there is a threshold, when the carbon intensity goes above a certain threshold. You can scale a job or a deployment in a certain region. You can scale it up somewhere else. So you can maximize or minimize maximize efficiency and minimize the emission for your workloads. It's a great project. It's based on Kepler, which is also a project within the Target Environmental Sustainability in CNCF, a CNCF project that measures the emission of Kubernetes workloads based on eBPF, and it's very, very interesting project. So I'm not going to talk about this. Actually, the project seems to be a bit stalled, but I'm looking forward to contribute to that as well. So that's something we want to I want you to be aware that you can scale on different things, and in this day and age, there will be no proper presentation without talking about AI and LLM. Of course, you can all this model stuff, right? So it runs mainly on Kubernetes, and so you can use KEDA. I haven't done any of this, but I would. And I think I saw some example online, but that's something very, very early stage. So imagine you can have some way to measure the model quality, as in you can run some prompts, check the results against that benchmark, and then have KEDA running a training job based on the model quality. So maybe the model is over time becoming less and less accurate in its prediction or in its responses, and then you can retrain a model based on the quality of the responses. And how do you train the model? There's another project called Kaito, the Kubernetes AI Toolkit Operator or Toolchain Operator, that runs models in Kubernetes, not only the AKS, but is a generic open source project. So imagine you can trigger that based on events that KEDA can understand. So if you want to work on this stuff, like I'll be happy to talk about. Today we're gonna show instead how to respond to signals in the sense of message in a queue. So Azure Service Bus, it's IMQP compatible tool service in Azure, which replicates or emulates, or it acts as a message queue. So we can put messages in a queue, then scale the consumer based on the number of messages in the queue. So very simple demo. It's not something that it's gonna blow your mind, but I'm gonna show how this works, right? So how to get it done. So how it works: KEDA will monitor the queue, the service bus, when I run the load testing, and I'm gonna use Azure Load Test for this. I can also use local JMeter, depends on how I feel the day, but using Azure Load Test allows you to automate this, right? So you can automate load testing your service bus with messages and make sure that your infrastructure is ready to process the messages as they come in. So, and then KEDA will change the horizontal pod autoscaler based on how many messages are in the queue, and then we're going to observe this with Azure Managed Grafana, which directly connects to Service Bus through the Azure Monitor plugin. So we can see immediately, we can see the effect on the message side, on the message queue size, the effect of scaling on the message queue size. So, well, I talk a lot, but let's see if I can get this thing done. Yes, so let me start from Azure. By the way, there's the repo is here. I started a new demos repository, so I plan to put all the demos that I'm gonna produce in the coming months in this repo. So watch it for more demos coming. And so this is basically it, right? So I already have a cluster, an AKS cluster. You can see that you can just enable the add-on, right? So nothing really, you don't need to install anything, but when you create the cluster, you can just enable. You can enable the add-on after you create the cluster, and it works just the same. And if you can see my terminal as well. Thought I had this. One second. Let me just get the right kubeconfig for me. Yes. kubectl get pods. In kubesystem, you will notice there's a bunch of KEDA pods, right? So, and that's just KEDA, right? So this has been installed by Azure and it's supported. So it's I didn't install it; it just comes out of the box with my AKS cluster. So it's admission webhook and the operator and the API server for the metrics that feeds into the HPE. So I don't have. This is clear, right? This is clean. I did pre-create, of course, the service bus namespace, the service bus queue. I got the connection string saved as a secret. kubectl get secret. Of course, I have a connection string in there. Right. That's it. So now let's move on. I'll grab this. Sorry for the confusion. Oh, again. Yeah, this is better. So you get the service bus. I don't know if it's. Oh, yeah. You create a trigger authentication. So how does KEDA sees the service bus? Well, you need some form of authentication, and that's the trigger authentication object right there. So I create this trigger authentication object. If you are curious, there's a bunch of objects, of course, made that belong to KEDA. I don't know any. So I made a trigger authentication, which is a namespace scope. There's also cluster trigger authentications, which are cluster scopes, but we're not gonna need that for now. But we do want to. We did create this trigger authentication to authenticate against the service bus, and then I create a deployment. Right. So the deployment is a simple thing. So, and the source is also in there. This consumer app is a very simple app that consumes messages from a queue. So I just added a small variable delay because I want to make sure that I can control what my consumer does, so I can slow it down or make it as fast as possible. So now I have just one pod, right? So, and you can see the logs just listening to my queue. Now back to Azure. This is my queue. It's empty. Oh, by the way, when I create the queue, and this is something I really I put it there for my own convenience. You see this, when I create the queue, I put this default message time to live PTT10M. I had to figure it out. Actually, this is 10 minutes. So it's, if a message stays in the queue for more than 10 minutes, service bus is going to delete it. So because I didn't want to leave messages in the queue for no reason, so I wanted to start fresh all the time. So you see now the queue has 0 messages, right? So not only that, of course, I also have a Grafana resource. It's a Grafana resource. Of course, you also have a Grafana. Let me see. So Grafana is amazing, of course, everybody loves it, but who has the time to deploy Grafana, especially when you can just deploy it in Azure? Simple as that. And I made a small dashboard. It's also in here. So it's the service bus. The JSON is there. So this is the dashboard. So it's simple, nothing crazy. Shows the messages in the queue. Finally, of course, we need to have a. So let's see what happens when there is no KEDA, right? So I didn't create any scaled object. There's only one consumer that can. This doesn't work, so what I'm gonna do, I'm gonna use JMeter directly. So from my machine, so to say. So why it doesn't work? So this is also part of the why we build demos, also to understand that things tend to work or tend not to work. So what I'm trying to do here is to use I know because I have some time, so I wanted to show you that not everybody's perfect. So the way, I don't know if you ever use Azure Load Test, which is an amazing tool, right? So an amazing piece of software in Azure, and I'm gonna do this, right? So the way it works is that it relies on JMeter scripts. JMeter is from the Java world, but it's pretty standard way to do testing. It's a very popular tool. So you upload a JMeter script, But of course, in this JMeter script, you don't want to embed things like the shared access key of your service bus. You want to parameterize everything. So and I haven't done it. I mean, I haven't succeeded yet in getting this thing right. So this is the load testing, let's say, workspace, right? So then within it, you create a test by uploading your JMeter test, right? So you don't want to run it after creation. There's also locus script. I haven't touched that, but let's say that I want to create a JMeter test. You need to upload two things. One is the actual parameterized GMX file, so the JMeter, and then you also need to upload the service bus plugin. So literally, this plugin, this jar you download from the official. It's a plugin for JMeter that understand how to work with service bus. You have to tell load test that which one is the main test script. So and then these things get uploaded to a blob storage for being used later. What it's not working for me, and that's why I'm going to use JMeter on my own machine, is that you want to use variables, right? So you don't want to have a script, because the script that I'm going to use here in JMeter, all these parameters are kind of are coded, right? So and the access key is also in the XML file. So you don't want that. You want to have as much as possible parameters, so you can use the same test for different service bus, for example. But I haven't done it yet. I'm lost in the XML magic of JMeter. But so what I'm gonna do here, which is much easier, I'm gonna delete this, create a test, and instead of this parameterized, I call it test static, for example. I don't want to run it after. And then instead of this file, yeah, I'm gonna use this manual thing, which is the one that has all the parameters are coded, right? So I'm gonna do main test script, and this is where things get complicated when I try to parameterize. So the secret that contains the service bus connection string has to live in key vault, and that's where things go wrong. And how does Azure Load Test access that key vault? Through a system managed system assigned identity. And I don't know what's going on, what's wrong, but in general, like, this doesn't work. But this being the hard-coded version of the script, I don't need to worry too much. One thing that you can do here, of course, so you can also change the number of instances that you want to use, but you can also add. So the testing is not just load testing; is also important part of testing is also measuring what's going on, measuring the effect of your test. So you can connect Azure resource to the test. In this case, I want to connect the service bus namespace, and so I can see it. I can see in the page of my test, I can see the effect of my tests on. Okay, I call it in a strange way, but I don't know why it auto-completed. Let me rename it. KEDA hard-coded. Yeah. Let me change the name. I don't know why my browser remembered that particular name, but I change it now. So KEDA hard-coded. It takes 10 seconds because it's actually uploading the scripts to see if I do run now. It's not gonna. Oh, well, it's already uploaded. So, but in fact, like, it's very funny. So they actually, the scripts are actually uploaded to some Azure blob, so they can be run from there. So, and then you can run this test and low and behold. So this is, I use 10 test engine, and the thing is that's really annoying is that it takes some time, right? So it takes a few seconds or 10, 20 seconds to actually run. It's like the same thing with GitHub runners, right? So, or Azure DevOps agents, right? So it needs to be provisioned by Azure. So these are virtual machine, I suppose, or I hope not. I hope they are containers somewhere that actually need to spin up and load test my my service bus. So
Question: Is
yeah.
there so like, you know how like with VS Code, for example, you can sign into Azure and then deploy, you know, app services or to Kubernetes or whatever? Is there like an extension to be able to like run the scripts from there versus like copying them around? Or
good point. Not that I know of. When I started looking at this, I kind of said JMeter Java. Okay, that's so I was also like, I wish I didn't need to run this JMeter thing. But no, I don't know actually. What I'm looking forward is to maybe do this in Locust.
right,
It seems to be a bit more, also Java, by the way, I think.
Oh.
But maybe something that can ease my pain of JMeter.
Yeah,
So you see, okay, so this let's give it some time. I can run it from JMeter itself with all things are coded. You can set, of course, like let's say that you want to run 10 tests. You want to run it for 10 times, right? So this very classical. I mean, it's just as soon as I run this test, right? So this is JMeter from my machine connecting. My consumer is actually processing messages. It's pretty fast, right? So you can actually barely see it. If you go to demo queue, you will see a bump in the number of you see number of pods in real state. So these are the number of pods. Don't worry about it. But we still have one pod here. So I couldn't, with Azure Monitor, I couldn't get the number of pods for a namespace. I couldn't filter by namespace. So this is the number of pods in the whole cluster. So don't take it as a number of pods. But I just want to show that there's going to be a bump because I'm bumping the number. So bumping using KEDA. Nothing really happened because as soon as the messages are created, the single pod is able to consume them all. Because on the other hand, I didn't use a lot, right? So I use just a little. And this was my test from JMeter. Now, and because this isn't even started yet, and that's why I'm not going to use load test. But imagine you can also run this load test on a regular basis and make sure that you can that these things are repeatable, right? So I'm not gonna wait for this, but I just want to show you if I run more tests. Let's say that always using my JMeter, right? So in this time I'm gonna bump it up. Now I'm pushing more and more messages in the queue using my JMeter, of course. You can see now some patience. Now you can see that the number of messages in the queue is actually significant, right? So 3,200, and it stays there, right? So, and this could translate in a. Now I'm simulating like a pretty heavily used service bus queue. You can see there's things are eating up pretty quickly. This even so this is all based on the same sources, right? So either this visualization from the portal or the service bus, it comes from the same place, right? So it comes from the same Azure monitor, right? So you can see 3,000. It's the single consumer, because this is not, the poor guy is just trying to consume messages as much as he can, but it doesn't work. So now let's try to get a scaled object. Let's get a scaled object in. So the scale object is, it says like this. So I need to export. Queue name is demo queue. Right, and then my thing ran out of memory, but I think so. Now I create a scale object, scaled object, min and max 10. There's still one, but because I set some, there you go. So now it's scaling up KEDA. KEDA is scaling up my pods. Let's see. So we left the queue at almost 7,000 messages. And now I see my message count going down because I have now 10 consumers. I think you can see it also in here. At some point, my total number of pods should go up by 10 because now 29 is the basic number of pods, just the system pods plus the one in the default namespace. But with some luck and some patience, so it's the first skill to learn when you work Kubernetes is patience, of course, but that's how it works. So, and now I can see that 10 pods are actually effectively consuming the messages in my queue. By the way, my JMeter is still running. Yes, some of my threads are actually out of memory. Sorry, and I do have a 64 gigabyte laptop, so that's why you want to run these things in the cloud with Azure Load Test, because you don't. Now my machine is total. I'm killing my machine because I'm running 100 threads of this. Of course, it's Java, so it doesn't help. But the thing is, what I want to show you, if we have just a couple of more minutes, I know we are running over time, but there's a threshold here. The threshold is, what is it? Yeah, when message count goes below 50, which could happen pretty soon, there would be a scaled down event. And I'm clicking like a crazy person, but in the end, like 10 consumers are pretty. In fact, like now already a few were terminated, like 4. So I mean, I think now I'm at 6. Yeah, 6. And more are being terminated. 1, 2, 3, 4, 5 now. So I'm back to actually 1. And only because I said this, what did I set it to? Between 0 and 10, right? In fact, soon enough, you will see when the queue goes to 0. And I think because I'm gonna stop my JMeter now because it's really shutting down all threads. So eventually this is gonna go to 0, but don't know why. 1 messages, and then eventually even this pod, because this is a scale to 0 scaled object, right? So eventually the queue gets empty. Yeah, there you go. So now there is no pause anymore. It's still there. I mean, the deployment is there. It's a 0 replica. And I didn't show you this, but of course, the scale object triggered the creation of a horizontal pod autoscaler that actually controls the deployment. So this is a scale to 0 reactive system that reacts on the number of messages in the queue. And we demonstrated, and this concludes my demo, which went better than I expected, even if, and I can see also in Grafana, by the way, that the moment I activated the, I could have left it here for a little while to show you, to show that one pod wouldn't be enough, but then I think also if you wait a little, yes, now the number of pods is actually back to 0. So it's not immediate, but at least you don't see these things real time in the monitoring, but it's close enough. Okay, so this concludes the demo, which I say it went better than I expected. Of course, we demonstrated Azure role test, which is good, but I'm still working the details, especially when you want to parameterize and use secrets for your test. Managed Grafana, great. The managed Grafana is actually pretty awesome because I didn't really need to configure much about it. I just add the data source. I think it was already there, and I created a dashboard that just used the source and just shows it can just connect to the service bus namespace and so on. So it's very, very cool thing, cool trick up your sleeve. We demonstrated KEDA, how to create a scaled object and let it do the magic, consume, make sure that you have enough consumers to, let go of all the messages so you don't back up your queue. So my takeaways is always adapt apps to workloads. Don't let apps run statically. Don't let deployments have a replica number that doesn't change with time. Always stay close to the actual consumption. Go beyond the basics, so that just don't stop learning. I learn every day, so now I learn JMeter and Java of all the things. Learn KEDA, which is pretty cool, and enjoy the weekend. It's Friday, so in this beautiful weather in Amsterdam, and I hope also where you are. So I'm gonna not stop sharing, but at least I can, if there's any question on.
Oh, nice demo. I wish I had the weather here because in England it's looking very grim, which isn't nice. But yeah,
looks like in the rain. Yeah.
Oh no. Sorry to you guys. It's King's Day in Amsterdam, in the Netherlands. So it's the birthday of the king. So we're gonna have a big celebration. It's I don't know if you know, guys. So little things about the Netherlands. It's the only day where you can actually sell things on the street. So King's Day in the Netherlands is a big celebration. We have boxes full of old stuff. The kids are gonna sell them, and that's and then we party, and it's pretty fun. You have to wear orange. Yeah, it's oh man, it's you gotta see it to believe it. It's one of the most intense celebration in the Netherlands.
That's awesome.
Yeah,
that's cool. I have to hopefully get some pictures from my colleagues because most of them are based in the Netherlands. So hopefully they'll send over some cool pictures of everyone dressed up as orange, which will be cool.
Yeah, I'm not a fan of monarchies, but hey, sometimes it's nice to.
yeah, too right. I wish we had a day for the king here, but no, we don't get anything like that.
Okay, Alessandro, can we have your GitHub URL so we can put it in the comments?
Of course.
In case anyone want to know.
Yes.
Just in case anyone want to try a demo out.
Of course. I think it's this one. It's my. I'll share the slides as well, so it's all
Okay,
there.
cool.
Awesome. That was a
And it's
really
easy
good
to
demo.
remember. It's IMS like Amsterdam 0. That's my GitHub.
Oh, okay.
That's a good GitHub name. How'd you manage to
Nice.
get one so short? Must
I
have had that for years.
do love Amsterdam. I'm here for 20 years. Call it home. It's a beautiful place. This year is 750 years old. So it's like living in a dream, like living in the Middle Ages. It's pretty cool.
Nice. Oh, cool.
And KubeCon is coming back next year. So
Yes, it is. Yeah, I'm excited for that one. It was a good event. Is it the RVI or something? Or something like that?
In the
building?
RAI.
Yeah, the RAI. That's it. Yeah.
It's not central, but it's good enough. And that's plus the parties and the vibe.
Yeah, it was one of my favorite KubeCons. That one.
Yeah. Can only be better, right?
Yeah, definitely.
Hey, London wasn't bad. I mean,
the thing with London for me, it was split over the two halls, so everyone wasn't together. Whereas KubeCon Amsterdam, it's just that one big giant place, and it was nice. And then you have the food bit over there with the project pavilions, which was separated. And I actually liked it that they were separated. Not many people like it that they're separated, but I did because it wasn't as loud. You could actually go and have a chat with them properly. But a lot of people love it that they're joined in with the main section now. But yeah, not me.
Valencia was like that, and it's okay. It's one big circus, and
yes,
can't wait for the next one. But it's always like I'm so tired, I can't take it anymore. And then the week after, I wish there were maybe a couple of more days.
This London one went so quick compared to the other ones as well. It was weird. Maybe because I'm from the UK, so travel was a lot easier. But
and you were at the AKS Day, but we were also at the best part is always the rejects, right? So which is
I went for half a day
okay.
of the rejects. It was good.
Such a nice conference they run. If you can go to rejects, do it. It's I know it's weekend, and I always promise my family I will make it up to them. Extra daddy time on the next weekend, but
nice.
Awesome.
Cool.
Brilliant. And I guess with that, we're pretty much time to wrap up. Yeah.
Awesome.
It's good to be back. I like it. I enjoyed it.
Yeah. Awesome.
Azure Cloud Native. That's one of many.
Thanks for everybody for watching. We right now we have 145 people on, which is a lot for a live stream. So that's awesome.
Yeah.
Okay.
Thank you very much, everyone.
If you got any question, you can just ping Alessandro or ping one of us, and then we can send it to him regarding this demo.
Sounds good. All right, everybody. Thank you so much for watching. Really appreciate it.
See you next time.
Thank you, folks.
Thank you. Bye.
Bye.